So good morning, everyone. I'm Fabrice Fitch. I'm a composer and musicologist, specializing in the research into early Renaissance music in particular. So first, I'd like to thank Jonathan Impett and the organizers of this symposium for the honor of the invitation to such a fascinating event. For my contribution today, I'd like to consider what algorithmic approaches might bring to bear on a specific research problem in my current musicological practice. Now, that my compositional practice doesn't run in that direction is due more to my lack of aptitude than any unwillingness. I'm personally aware of several composers, both professionally established and students, for whom it is an integral part of their pre-compositional work at the very least. But the issues I want to explore will, I hope, have a wider applicability than this case study. I've recently completed a reconstruction or restoration of an entire polyphonic mass that survives only as a fragment. Of the set of 4 part books that are the sole extant source for Jacob Obrecht's Missa Scaramella, only 2 are extant. The other 2, containing the top voice and the tenor, have been lost, meaning that in theory at least exactly half of the material has had to be recomposed. I say in theory because in practice a good deal of the tenor is deducible because this is a cantus firmus mass based on a known cantus firmus, Scaramella, meaning that many cantus firmus statements, which are usually in the tenor, are easily identified. But at other times it's not so easy because Obrecht is prone to do arcane and rather kinky things with his cantus firmi. Identifying them is a real detective work when you're looking at it from the standpoint of it being unknown. And I've been fortunate to rediscover some fairly abstruse but very elegant cantus firmus statements, elegant because underpinned by Obrecht's sophisticated use of his native mensural notation. Just to give you an example of what I call a kind of kinky way of treating your cantus firmus, one is to say, for example, to the singer, right, you start reading your cantus firmus, you sing all the notes, all the long notes in the order in which they appear. Then you go back to the start, and then you sing all the breve notes, middle length notes in the order in which they appear. And then you go back to the start and you sing all the short notes in the order in which they appear. And then in the next movement, you're going to do the same thing backwards. So good luck finding that. Let me show you one of the things that I've reconstructed. This is just a little information on the sources. I should have shown that slide earlier. Right. Let me show you one of these statements. Here, Obrecht takes the pitches of the Scaramella tune, as you can see, and assigns to them the same duration, and then parses them in groups of 3. First 3 white semibreves, then 3 black ones, then white again, and so on. Black notation reduces the note's duration by 1/3, effectively creating hemiola, so that groups of 3 black notes are worth 2 white ones. At the end of this process, as you can see near the end of the first line, there's a repeat sign, and then the singer is instructed to sing the same passage again, but with a verbal instruction telling him to invert the color scheme and read the black notes as white notes and vice versa. The point of this example is that the notational conceit on which this passage relies makes it virtually certain that the pitches and rhythms of the tenor are the correct ones. Though there may be points of slippage where the durations admit of slightly different solutions, they could not be expressed in the encoded notation that we have here. Now that leaves the top line, which for the most part is freely composed. And it involves a different set of resources, less detective work, more knowledge of contrapuntal style, and the formal conventions pertaining to the genre of the early Renaissance Mass. Here it helps that we have nearly 36 Mass cycles ascribed or plausibly attributed to Obrecht. But it's fair to say that at this point, my musicological and compositional faculties are jointly mobilized to their fullest extent. It's been a hugely rewarding project. Now to the sorts of questions that concern us today, I imagine. To begin with, the sort of thing one often hears about in the news, could AI credibly generate a Renaissance Mass in the style of Obrecht? I suspect the answer, at least for the time being, is still no, because mimicking the formal contingencies of a Renaissance Mass or a sonata form movement, as opposed to a simple binary or ternary form, say, may yet require a vast amount of human-led machine learning. To make an analogy with the visual arts, it's often said that AI can now generate the image of an apple in the style of Cézanne, but with the qualification that it's a 2D image. Even given the most sophisticated 3D printer, I suspect that it could not yet generate a painted surface mimicking Cézanne's technique on the level of the individual brushstroke, sufficient to fool an expert. And saying this, there's probably enough expertise in this room to tell me whether my hunch is right or not. So let me turn instead to the tasks that I imagine that AI could be trained to solve using algorithms, given this particular project. First, a relatively straightforward example. Given a polyphonic work in which a cantus firmus tenor part is missing, lost, one might ask AI to identify possible successions of tenor pitches to fit the extant parts. Next, let us assume that the computer had at its disposal the entire corpus of medieval plain chant. It could then identify those that most closely satisfied the possible successions of pitches, eliminating in the process any successions of pitches that did not correspond to known plain chants. This is not actually a hypothetical problem. I've recently been asked to do this very thing for a large-scale 15th century motet, and not being a chant expert, such a program would hugely facilitate what feels right now like a needle in a haystack sort of problem. To take another situation with which I've been directly confronted in the Scaramella project, one of the extant in two of the sections of the Mass, one of the extant parts consists entirely of short snippets of material. This is on it's on the first three systems of that page, the first three staves, sorry. You can see that it's entirely consists of snippets of material, each of which is repeated, you see the repeat signs, before you move on to the next one. On its own, doing this is no great compositional challenge. Here's the other voice in another movement that does the same thing, both Hosanna movements. You can see this is in the third and fourth line. You see the repeat signs. You basically repeat each segment, and then you move on. As I say, on its own, this is no great challenge, but in both cases, Obrecht does this against a cantus firmus statement in another voice. Now, that is much harder to do. Let do it in a way that's melodically convincing and consistent with Obrecht's style. But to cut a long story short, I deduced that such a strategy very likely informed one of the missing voices in another section. So I set to work, and the process took several weeks. First, one must identify segments within the extant voices that will allow such repetitions in the voice you're composing, starting with more readily identifiable ones, and then working outwards from each and gradually link them up. But where you can't contrive to fill the space between two existing segments with one or more other segments, you have to modify the durations of the initial segments and then try again to fill the space between them. And if that doesn't work, you have to start again. It's a matter of trial and error. But a computer trained in the rules of contrapuntal grammar and musical style could instantly generate an array of possibilities, that's to say, all the available possibilities, from which one can select the most satisfactory and then refine them. To a more general compositional point, algorithmic generation has the advantage of identifying possibilities that might not suggest themselves to the individual composer, and of doing so instantly. But as my example of the missing cantus firmus tenors shows, all these tasks require overcoming one very banal hurdle, namely data capture. I was recently involved in a project involving the data searching of the 16th century so-called imitation masses, what used to be known as parody masses, which aimed to identify compositional strategies down to the level of the local contrapuntal detail. The main obstacle is the difficulty of inputting the raw materials, that is, the scores, in a form compatible with machine learning and reading. Until now, data entry has had to be done manually, so that fewer than 100 masses are currently available to search. That's about 10% of the total of imitation masses that survive. It's an infinitesimal amount of data in terms of machine learning. At any rate, it's not enough to address the repertory-wide questions with which AI could actually assist us. This returns me to the question how far AI can generate works in any style of any Western art music, as opposed to something that merely sounds like it. And here I return to Obrecht's puzzles, whose notation is so integral to their conception. I wonder whether notation, or a close analog of it, might not serve a similar self-corrective function in an AI attempt at reproducing a classical symphony, or why not a Klavierstück by Stockhausen. Maybe one of the early ones anyway. Finally, rather than ask AI to generate music in the style of X or in a particular mood, one might simply begin by instructing it to make music and hearing what happens. Thank you.
Section. Okay. I want to ask, why is the music score quite different from the one we used right now? Is it some kind of specific score from in pre-Renaissance?
Yes. This is what you see here is the original manuscript, and this is how the music was copied. So what you see is actually, I mean, it looks reasonably similar to our own notation. What I did here was a was a typeset example of the same kind of thing, just done with software, just to keep it consistent. It has no meaningful, well, this example has no meaningful difference as far as durations and pitches are concerned. It's just that the note shapes are slightly different.
Okay. Yeah. Okay, thank you.
Sure.
Is it known, maybe in the Renaissance, were there magic squares used for composition at some point? Have you heard about this?
There were probably things like that, not exactly magic squares, but we know that there are ancestors to the things that in the Baroque are called partimenti, which is ways of combining, you know, if such a note, then another note. I had an experience with a senior colleague who was basically getting a room full of musicologists and students to start doing canons and writing them out instantly with just a very few rules. And so it's these sorts of things certainly existed. We don't have many that are that early.
Thank you so much.